Bismillah ar-Rahman ar-Rahim. Welcome everybody to this presentation. My research paper is about natural resources conservation service approach for curve number estimation for some Jeddah region, arid basins, Saudi Arabia, for water sustainability studies. Actually, this work is done by Muhammad Farran, Dr. Nasr Al-Amri, and myself. I'm going to give the presentation on behalf of my student Muhammad Farran. This is from King Abdulaziz University, a Department of Water Resources, Faculty of Meteorology, Environment, and Arid Land Agriculture. Presentation, the layout of the presentation, I give just a short introduction, problem statement, objectives, study area, methodology, results, and conclusions. For introduction, we have actually for sustainability of water resources studies at a basin scale, a hydrological model should be developed to study the water budget in the basin in order to study sustainability issues. The natural resources conservation service curve number method is the commonly used technique for modeling rainfall runoff processes at a basin scale. The NRCS relies on two parameters. These parameters are called the abstraction ratio, lambda, and the curve number, or NRCS curve number. These two parameters are the main concern in modeling rainfall runoff processes at a catchment scale. The common value for this parameter lambda is actually 0.2, which we'll discuss later. However, many researchers have shown that this parameter could vary between 0 to 0.3, and these are some recent studies which were already done in 2020. So our problem statement can be formulated like that. Saudi Arabia is one of the arid regions that lack specific studies related to estimation of curve number from field data, since runoff stations are absent in most of the basins. Therefore, any attempt to analyze the available rainfall runoff data from field observation will improve our understanding of the hydrological processes in arid regions in general and in Saudi Arabia in particular. And therefore, we can build realistic catchment models for water resources sustainability studies. So our objectives in this research can be, set as these three main objectives, which will focus on a main objective. So the first objective is, I try to formulate in research questions, like what are the appropriate values of NRCSCN and lambda in the Jeddah region, because my study area will be focusing on Jeddah. The second objective is to compare the NRCSCN theory with the rainfall runoff observations at different values of lambda to see which one is the best to fit the data. Later on, we go to objective number 3. Can the NRC theory be generalized for both Jeddah regions and southwestern part of Saudi Arabia? Because we already have done studies on southwestern part of Saudi Arabia. And this paper is focusing on Jeddah basins. So we wanted also to compare and see if they will both, can be generalized. So the main objective of these questions will come up to this main objective, which develop an appropriate rainfall runoff model for arid basins based on realistic values of in Cn and lambda that can be used further on for water resources development or sustainability issues in the region. The area, so actually, we will focus on two study areas, but the main focus in this paper will be on the area on the red corner here. We have some basins in Jeddah region, and also we have from previous studies we have also this blue square, which is some basins in the southwestern part of Saudi Arabia. Are the shape of these basins. This is the name of these basins. I don't want just to mention the name, just you may notice the shape of the basins. You see the basins, have completely different shapes, elongated or even, short one. So they really vary a lot in geomorphological and shapes. The southwestern part basins are these ones, which are, also this is studied by earlier work, and that's what we are going to compare here. Data and methodology. So our data actually, we have about 30 storms in Jeddah basins, while in the southwestern part we have about 161 storms. So these are the data, and the data is actually rainfall runoff data, which you can hardly find runoff data available in arid basins. The methods which are going to use in this study will be about the NRCS CN method, and also we use the least square method to estimate the parameter. So our model, this is actually the equation for this CN method. So it's actually we have here, this is the balance equation. I mean by the balance equation that we have the inflow, what's getting in and what's getting out. So we have the F is actually the outflow, the infiltration, the amount of water infiltrated to the ground. We have P is actually rainfall, Q is runoff, and IA is actually what we call initial abstraction loss. So this is actually the balance equation formulated in terms of that we get here our recharge, or what we call infiltration, is actually equal to the precipitation coming to from the air, the precipitation minus the runoff minus the initial abstraction. And this initial abstraction is actually equal to a parameter called lambda times S, and S is called the maximum retention of the basin, so which is actually given by this formula. So this is actually the equation for S, which is actually depending on precipitation and runoff. So actually, these equations can be formulated to also to get the outflow. Reformulate to get the outflow, which is the runoff, which is, put in this. So just rearrangement of the equation. So I don't want to go in details, but I just give some idea about the type of equation we are using. Methodology, so we'll rely on these equations. So we have three methods to estimate the parameters Cn and lambda. The first method is based on the least square estimation, which we got something called CN best and lambda best. And we have another method that we can use. Given lambda, we can get CN, knowing precipitation and runoff. And the last one is giving lambda equal to 0.01, the value which we prefer, it's better value for arid basins. And this is actually, we can estimate CN based on that. So actually, this is the formulation for least square method, that we can estimate our runoff from the equation, from the model, from the SCS method, and then we can compare this outflow or the runoff with the observation, and then we can minimize the difference squared, and then try to solve this optimization problem and find out the CN and lambda that fit with this in this optimization problem. The results. So what we end up here, we come up with, this is the runoff Q, and this is precipitation in the horizontal axis, and this is at lambda 0.2 and at lambda 0.01. So you see the data, the dots are the data, and the green one are the data for Jeddah region, and the red ones are the data for the southwestern part region. And then we get CN, which is about 70 for Jeddah region, and we got here about 66 for the southwestern part region. And if we consider all data, so we get something about 66 CN value. While if we take 0.01, which is lambda for the initial abstraction ratio, so we got these values. So the fit even looks better here. So for it's about 54 for Jeddah region, and CN equal to here about 36 for the southwestern part, while it is 42 for the both. So what are the implication of this, or what are the meaning of? Yeah, before we go to that, I also focus here on some comparison between only for Jeddah region. I compare the CN for lambda 0.2 and lambda 0.01, and then we found this different shapes. You see different fits, but it looks like the fit for lambda equal 0.01 is somehow better than this one, but we will compare this quantitatively later on. But there is also a study by Institute of Hydrology in 1985, and they put a line fit to the data. So you end up with a line like this, which actually seems to be actually not a good representation of the basin characteristics. So when we did some kind of more quantitative assessment of the results, we found out that this is for Jeddah, and this is for Jeddah, but at different lambda, and lambda 0.2 and lambda 0.01, and this is for the southwestern part, also for lambda 0.2 and lambda 0.01. So then what we found out from this, if we look to this one, you don't see a quite strong difference, although this still give the least root mean square error and the highest R square than the one with lambda 0.2. So that we prefer that to use lambda 0.1 for these basins. So we can come up with this conclusion. I mean, yeah, shortly, just for time, I mean, the initial abstraction ratio lambda best was found to be 0 for Jeddah region. But this value is falling within the limits of the common range obtained in the literature, which is between 0 and 0.3. However, the use of 0.01 seems to be more realistic, since it accounts for some initial abstraction that for sure will take place in the beginning of the storm. The second conclusion is that the value of lambda 0.1 is more suited to these arid regions rather than the common value 0.2. So then this is also what we also found out, even for the southwestern part was strong. I mean, this influence was quite strong in the southwestern part. Since it leads to low value of Cn that accounts for the transmission losses in the wadi, because this is a common feature of the arid basins, that there is transmission losses in ephemeral streams. And this, by taking lambda equal to 0.01, it leads to lower Cn. And this lower Cn means that you have losses due to transmission of the flood through the catchment. And that's what's really happening in reality. And this also has been confirmed by previous studies as well. So the last, number 3 here, we have a comparison of estimated Cn with different lambda, 0.01 and 0.2. And then we found out, that between also the Jeddah region and the southwestern part region, and it showed that we have highest Cn value for Jeddah basins. So Jeddah basin has higher Cn values than in the southwestern part. And the reason for that is that we have really high runoff observed for this basin in Jeddah. And this is of this high Cn event at low rainfall depths, but with short duration. The rainfall was short, but we have was small, but we have short duration, which means you have high intensity rainfall happens in this Jeddah basin, and that's why lead to high runoff and high Cn. The last comments here, the last conclusion here, then the NEC models with the estimated parameter of lambda and NRCS Cn of this basin can be used as an appropriate rainfall runoff model for sustainable water resources in the region. So that's what we already, the values obtained from this study can be used to construct a model for these basins, and can be used later on for sustainability studies in the region. Thank you for your attention.